So we're going to look at our design software, go over these topics here. The emphasis is going to be on number 4 there, the analyzing and optimizing tools. And on the first ones, I'm going to go over them a bit higher level, but I'm going to point out where we've got video tutorials available on our website as well. So if you want to see any more on those topics, you can do it. And if I get my timing right, we'll have time for some questions after, and happy to do that. And so I'm going to get right into it because the hour's going to fly by for me, hopefully same for you. So our LoopGAT is our software for the radiant heating design, also snow melt. And so if you're not familiar with it, it lets you draw the floor plans, calculate the heat losses, design the radiant circuits, and does all the wonderful hydronic calculations. And it was also manufacturer or OEM editions that have the components and systems built in from the major radiant manufacturers, so you can do materials lists and so on. So just a couple things on what it is and what it isn't. So it's a system design and a sizing tool. It's not a finite element modeling. It's not going to give you those beautiful color pictures of showing the gradient of the temperatures through the floor or through the ground. And it's not energy simulation. It's not going to tell you your energy use through the year. But it is targeted to doing the design, sizing the system itself and the loads. And I'll mention this as we get along here, but there's tutorials again on the website that we can look at. So let's get right into the first topic of heat loss calculation. So and we're going to get into the software right away, but there's 3 different methods that we provide in the software that you can choose from. There's Active Manual J, which gives you US and Canadian locations. There's CSAF 280, which is Canada only. Those 2 in the software have heating and cooling load options you can choose from. And then we also have ASHRAE, which gives you worldwide locations. It's currently just heating loads, and that's not an ASHRAE limitation. That's just where the software is at right now. And just a note that a knowledge of heat loss calculations is required to use the software. So it's not intended as a learning tool. You're not going to give this to someone and say you're now our heating expert. And it's not really intended for DIY unless the DIY is in the industry and knows what they're doing with it. Okay, so I'm going to flip over to the software here. And I'm going to open up, to save time, I'm going to open up the project that's got the floor plan drawn already. So again, for time constraints, I'm not going to be able to show you all the details of drawing the floor plans. It is pretty easy to do. There's tools where you can import a PDF or CAD drawings and use that to trace over. And that makes things a lot quicker. You can also use these shape tools we've got here. For instance, I'll take something like this and drop a room on. And you'll see it's automatically calculating our heat loss as I do that. And if I just drag things around, it'll update the heat loss. If I drop a window on, again, it'll update things as we go. I'm just going to get rid of that, clean it up. So before we look a bit more at the rooms, I'm going to go back to the setting step. So this step, when you start a new project, there's a wizard that will prompt you for a lot of these questions, but I skipped over that. So I just wanted to show you, this is where you would choose if you're going to do heating or cooling, and you've got the 3 different methods here to choose from as well. And then based on that, you'll get your outdoor design, climate conditions. So we're in ASHRAE mode here, so we get the ASHRAE's full worldwide list. So for instance, if I wanted to get North Dakota, Bismarck, I get minus 11.9 for my heating design temperature. And that's the 99% value, meaning 99% of the time it's going to be warmer than that. But that's the design point. I think, I believe manual J is the same, and CSA uses 97.5. So here, on the construction tab, so here would be setting the defaults that you want to use in the project, but every component you can change individually. But if all your walls or most of your walls are one construction type, you can come in here and pick what that is, 2x4 construction. I'll pick the insulation that I want. You can also input your own information there if you want to. So I won't go through all the others. Basically the same for windows, doors, and so on. Basements or slab on grade, a little bit different. The ASHRAE method allows the use of the CSA method for downward losses. So we use this dialog where we can pick the configuration for our insulation in the basement here, and then we can set the values here as well. And the last one I just want to look at quickly here is the infiltration. So in the ASHRAE mode, it's actually a pretty straightforward setting. Picking the construction quality, it sets a leakage area and it'll do the calculations based on that. Infiltration, I mean, all three methods are fundamentally doing the same thing. They all have to obey the laws of physics, and heat loss through windows and walls is all pretty consistent. Probably some of the biggest differences would be the way the infiltration calculations are done and downward losses. And again, they're all trying to do the same thing, they just approach it differently. So, and infiltration is one that you probably know can have a dramatic effect on your total load. I mean, you change these settings and they can go from being 15% of your load to being 65% of your load. And I don't want to say it's a guess, but if the building's not built yet, there's some uncertainty with that, certainly. Okay, so I'm going to go back to the rooms. I'm just going to take a quick look at, say, one of the rooms, this bedroom. So as I mentioned, the loads are shown in the label here. A lot of times we'll be talking unit heat loss, so per square foot. And you can see here this 25.9. As I change anything, I'll make this window bigger, and that 25.9 is automatically updated. And any of the objects, including rooms, right click, get their properties. Rooms have a lot of properties, so there's tabs at the top here, but flip over here. This gives you a view of the calculations, the details for that room. So you can always look at those details. One thing I was going to point out, you might have noticed there's this blue dashed line just along these walls here, and that's the software automatically is detecting that's as a full partition, because I am not heating the garage, so it's at -12, and the adjacent room is at 70 degrees. So it'll automatically detect that temperature difference and calculate a heat loss for it. And any other of these internal walls, they don't have that because they're the same temperature on both sides. And anytime you want, you can hit this 3D view button up here, and you'll get this 3D look at what you've drawn. And part of it's a cool looking feature, but it also has some practical applications, and that it gives you a good visual look of your windows. Are they roughly the size I was thinking, or is it these tiny little windows? Because in 2D it's hard to see that, right? And unless you look at the actual properties. And the other key thing here is the stacking of the floor plans. Especially when you're importing drawings, sometimes they'll be off, and if they're not stacked properly, that'll affect your heat loss, and you get errors introduced there. Okay, last little quick look at things here. There's some other views under this analysis button. The one I wanted to show was this zones view. So this view will give you a shaded view of a colored shading of the different zones. And by default, the floor plan's one zone, but here I set it up with 4 zones already, so you can see a little legend up here as well. And we'll get more into zones as we dive into this. So let me flip back to my slides here. There's a few special cases that, again, for time constraints, I can't show you in the software, but I just wanted to mention that you can model these in the software, so walkout basements, and there's tutorials that show these as well. So there's some methods, recommended methods to model the slope grade for something like this, and so you get a good approximation for your heat losses. And the word approximation is important because all these calculations are somewhat an approximation. They're not, again, they're not say a finite element modeling tool that you're trying to get absolutely precise. These are again tended to get the sizing correct. Vaulted and cathedral ceiling. So again, method here is we extend the walls up from the lower room so that they're considered part of that room, and all these loads on the upper part end up being attributed down there. And last one is clerestory walls and windows. This is one where we don't have a way to draw it on the drawing right now, but you can go into the rooms and set up the properties with the size of the walls and construction and orientation and so on. We'll get into the radiant circuit design now. So we're going to touch on these topics here. And as we go through this, and let me go back to my same project. I'm just going to change back to my default view. So, and before I look at the circuits, I'm going to go back to my settings tab because I didn't look at this radiant settings tab here. So this is where you would set your, say your manifold, default manifold, and if it's one of the OEM editions, it'll have all their manifolds preloaded in there. Your fluid, if you have glycol or just 100% water, as well as maximum temperatures for your surface and water temperature, and your panels. So I set the default here to be, for the above grade panels to be a thin slab, but you could choose to have, say, plates, and then you'll have certain properties associated with it here. All right. So these again apply as defaults for the project, but you can change individual rooms if you need to. And you'll then have your recommended tube type, spacing. The program doesn't dynamically change the spacing on your drawing, but it lets you easily do that yourself to do some kind of what if scenarios on rooms and see what happens. And this delta T, of course, and then there's this enforced fixed delta T. I'm going to check it off, and that comes into play as we get further in here. Okay, so let's actually go down here to this bedroom, and move that label out of the way. So that all you really have to do to start drawing circuits, you take the circuit entry object, and you drop it where you want to start, and voila, draw some loops. And it gives you this label. It's not connected to the manifold yet, which, by the way, I forgot to put on, so let's do that now. The manifold object, you can put as many manifolds on as you want, and we'll look at those properties in a bit. I'm going to put one there for this project. So I haven't connected this to the manifold yet, but it shows what we've got so far. And this is where, if I would say, you know what, I want to see what happens with 6-inch, I can just right click and it'll redraw 6-inch. Okay, so I'm just going to undo that. Control Z. A few other easy ways to manipulate the pattern. One is a layout gallery. So for the current settings, which are single serpentine, it's going to give me other options I could do. So if I want vertical instead of horizontal lines, I can choose that. And if I want even more options, I go to circuit settings, and I can choose a different pattern type. So here, I've got the double serpentine with a fill in the center. And if I want, I can even say, let's do tighter spacing on the outside, 6-inch, and 12-inch on the inside. And it'll apply that for us. So once again, it updates the label. Now the label, right now, doesn't tell you a lot other than the length and spacing. But once we connect it to the manifold, it can then do the rest of the calculation. So that's simply, but you simply do that by right-clicking on that circuit entry, and you draw the path. Whatever path you want to get back to the manifold, you lock onto it and click. And now you can see my circuit and the label has changed. And if I hit update, I get my flows and delta G there as well. Okay, so that's the quick look at some of the automatic circuits. What I want to show you, and there is freehand mode where you can just draw whatever you want as well. Ideally, the automatic does, you can do most of your project with that, and you might have to do a little bit of editing to tweak it, but there's cases where freehand is just the best way to go in a certain room. This particular room, with a family kitchen, dining, kind of an open area, open concept, and this hallway, has a really irregular shape, right? And we've got loops already coming through it. The automatic algorithm's not going to do a great job on that. But to help with this, we built a tool called the circuit area layer, which if I right click and just choose edit circuit area, that creates a circuit area, which if I move it over, you see it's just a replica of the room shape. And what that lets me now edit that without editing the room. So if I want to split this into two, so I haven't changed the room, underlying room, but I've now got these two sections and I simplified it somewhat. So I'm going to go back to my circuits menu and I tell it to draw some circuits there. And it does it. And so by simplifying the shape, I was able to, it's still a relatively complex shape, but it's less than what it would have been. It draws that in. You're going to see, I mentioned the automatic hopefully does most. You'll see things like this, like why didn't it fill in this? And it simply, if we looked at the measurements, it couldn't maintain the 12-inch offset. So it said, I'm not going to go in there. But you look at that and say, well, I want that to fill in. You can just grab the end and drag it in. And it updates the length as you go. Let me move this out of the way. And you can do the same thing over here. You say, I'd like it to fill in that corner. But then you end up with this going through the wall and you don't want to show that. So another simple edit, you can right click and choose Insert Point. And what that does is simply breaks that line in two. So I can take this part of it and drag it up. Okay, so that gives us, again, if I hit update, it'll give us the calculations for the circuits. And we're going to look at those in a little more detail here. Before I move on, I mentioned I was going to look at the manifold properties. Now that we've got a few circuits connected, the property dialog shows what circuits are there and the details. It also gives you the option to change the manifold type, even the fluid type. So this is a case where, let me just cancel that. If my unheated garage, I decided I'm going to heat it, and I put some loops in there, but I want to have glycol going into those loops, but not the rest of the house. So the software will let you do that. I can right-click on the manifold that's dedicated to the garage and tell it there's glycol in it, and it'll do the calculations accordingly. All right, so a little quick jump back to my slides here. So there's these other topics that I've sort of touched on, which again, for timing, we're not going to look at in detail, but there's a lot of advanced editing tools for the circuits. There's a manual or freehand drawing, which sometimes that's just the best option. Multiple fluid types we just talked about a little bit. The last one, we have the ability to connect to manifolds on different floors. So if you've got a small project and you want the manifold in the basement to serve both the upper level and the basement, you can do that in the software as well. All right, let's quick check of where we're at. So we've drawn our floor plan. We've calculated our heat loss and designed our circuits. So are we done? And obviously the answer is no, because it would be a really short presentation. But the next step should be to analyze it a bit and see if we can optimize things. And we're going to look at these particular topics here. Before we dive right into it, just sort of want to talk about what it is we're trying to achieve, right? What's the problem? And then, the basic or fundamental issue is that we want to give the homeowners heating that's controllable, and so the rooms aren't too hot, not too cold, right? That's really the fundamental goal here. And we'd like to identify any issues at the design stage, not at after the installation stage. And so that's where the software, where the tools, the analysis tools can help identify some of those issues and let you do some what if scenarios to try to figure out what to do with them. All right, so now just a quick overview of what limitations or restrictions are in play that might stop us from having rooms that are not too hot or not too cold. And you know, one of the top level or primary things is the unit heat loss, the heat loss per unit area, and that's the heat loss of the room divided by the area of the heating panel, so in floor in a lot of cases. And obviously, if you can change that, you can change what the radiant panel has to do. The surface temperatures, you might just say, well, if I need more heat, I just crank up the temperature. And if I need less, I'll just crank it down. And technically, yes, but there's limitations on things like surface temperature, and one of them being for comfort. If there's people in the space, you know, it's typically talked about it being an 85-degree surface temperature. Sometimes it's the floor covering that has a different limit as well. So the software lets you set these in there and see what happens when you to the system when those are reached. So the way the surface temperature is calculated is based on the unit heat loss, and then it'll calculate what surface temperature do I need to give that much heat to the room. Then, once you have a surface temperature, then we have to calculate down to the water temperature. So now we're looking at the tubing here, the water in there, and to calculate how much hotter that has to be than the surface temperature is a function of panel resistance. And that's a big question in a lot of cases, and it can be very different if it's embedded in concrete versus heat transfer plates and so on. The tubing issues, the spacing, is going to have a pretty dramatic effect on that as well. The depth, if it's in concrete. Even the diameter is somewhat muted effect, but there's an effect on that as well. Floor covering makes sense. You put a big carpet on that, it's going to be harder to heat it. And available floor area. So if you've got a bunch of cabinets covering things, that's all going to affect how much surface area you have. And this last one sometimes gets forgotten, but the fluid return temperature can be a limitation. You know, this little example where I don't need a very hot water, I'm only feeding in 80, but my room's 70. If I say my design, though, I'm supposed to design with a delta T of 20, you obviously can't do that here because you can't return the water colder than the room. So there's limitations there that are going to come into play as well. Okay, so let's go to the projects. So I'm going to start with just this project. It's a two-room project, so we can look at a couple of things here. So just a very simple two-room project. I'll hit update. And I've drawn, I've inputted so they both got 10 BTU per square foot load. And I'm going to flip now to this next step, which is called system design. We're going to spend the rest of the time there. This step, when I first do it, it looks like nothing changes really, but let me just make this a bit smaller. There we go. So on this step, on the left side, there's several different views available. These are the analysis views. And on the right side is shows the water temperature, and you can even edit it here. And it shows the manifolds and circuits under it. So again, pretty simple, only two of each here. We're going to start, spend a lot of our time actually on the zone control issues view, which is the first one. And right now, you look at that and it doesn't look any different than the other step we're on, right? And just before we change that, I've got a spreadsheet that shows exactly that. And in yellow here is the basic equation that relates your flow to your heat output to your delta T. And in this case, it's pretty simple. We've got a delta T of 20. We've got a load of just over 2,500. The fluid constant is 500 for about 500 for water. And you calculate that, and you get 0.26, which is exactly what we get in the software. Both rooms are the same, both rooms get the same flow rate, and both have the same delta T. Now, just note that there is 2 delta T columns there, and we'll get into that in a second here. But so what I'm going to do now to make it maybe a little more real world is the second room here. I'm going to right click on that, and instead of 10 BTU per square foot, I'm going to make it 15. And you'll see what immediately happens. I change room 2, but it suddenly shades room 1 as red. And there's a little legend up here that tells you that it's indicating that you may have an overheating problem now in room 1. And why did that happen? And I forgot to mention the water temperature before was 94. You can see the water temperature is now bumped up to about 101. And because it's only one water supply, both manifolds are getting 101 now. So in this scenario, what's happening is, and this would be more of a real world situation where all the rooms don't have the same load, but you're getting a hotter water supply to room 1 than it needs. So hotter water means its average surface temperature is going to be more, its output is going to be more. And if I zoom in here, it shows you that right here. The load for this room is 10, but when it's on, it's getting 13, right? So there's some potential for overheating happening there. Okay, and again, just a very quick look at my spreadsheet. So we show that those calculations. Oh, by the way, this is where we start to get into the fixed delta T versus variable delta T. So I'm in fixed delta T mode. And in the software, what that does, it says, okay, that room 1, even though it's not at optimum conditions, I'm going to calculate my flow rate using the design delta T of 20. So my flow rate stays at 0.26 for that. But because of the higher temperature, my load goes up by 26%. Or sorry, not load, output. Output goes up by 26%. So I end up with you run those through that equation and you get a 25 delta T. So, we will often get, we sometimes get requests from users who say, look, I got an engineer who says every room has to be delta T of 20. It's got to be these flows, this, and that. And unfortunately, sometimes the answer is, well, that's just not physically possible, right? In this case, we've got partway there. We say, like, we're going to keep the flows designed at that delta T of 20. But in reality, if you leave it like this, you're going to be running that and keeping in mind we're running at, say, worst case conditions at that 99% level, you're going to be running it at a 25 degree delta T. And that's not a software limitation, that's just the physics that's going on. Okay? So let's go back here. So I'm going to now flip back and we're going to change it to variable delta T, which is just unchecking those boxes. And you might have noticed that it's a little bit less pink now, or it was darker red before. And you look at the numbers, it was overheated, it was at 13, now it's at 11. And what that's done just by changing that is told the software, okay, don't worry about keeping that flow rate at the same, let it throttle the flow down to try to match the load for that room. So it's done that here, and you can see, oops, I gotta scroll down to the next, in variable delta T. So it's done that here so that instead of being 0.26, it said, okay, we'll let the flow drop down to 0.18, which in the real world is what you do. The room's too hot, you go turn the valve down, right? But some people will still get confused, say, no, it's still delta T of 20. Well, it's not. Again, this equation has to be respected. It's going to be, by throttling the flow down, we're not overheating as much, only 9% now, because the average temperature of the floor is going to be less. But we're still overheating a bit, but our delta T is going to be 31. And that's, again, unfortunately, that's just the fundamentals of it. You're actually going to be operating that room at 31 at worst case conditions. If you're assuming that your design includes outdoor reset control for your water supply temperature, throughout most of the year, it'll be less than this because your temperatures will be less, okay? And this is also a point where you could say, well, why didn't it fully balance it out? Why is it still overheated at all? Drop the flow more. This is where our return temperature comes into play, because the room's at 70 and our supply temperature is at 101, so the most we can have is 31. So it caps it out. That's why we end up with still a little bit of overheating there. Okay, so next one. So there's a lot of complex calculations going on, and what's nice about these views is they'll show you things graphically that otherwise you'd have to dig through maybe spreadsheets full of numbers to try to figure them out. I'm going to open up just a slight variation on the project here. Still 2 rooms, but when I come to my system design step, you're going to see now what I've done is I left room 1 at 10 BTU, but I purposely made room 2 33, so quite a bit higher. So now room 1's much darker red, because you look at the numbers, it's being overheated more when it's on. And room 2 though is actually blue, meaning it's underheated. So we've got the worst case here. One room is overheated, the other room is underheated. Okay, so what can we do with that? So, and a quick look at, you might say, why is this one suddenly underheated? If we go to our second view here, which is heating surface temperature, it shows you the surface temperature that under the conditions, and hopefully it's obvious. What's happened is it's hit the 85-degree maximum temperature that we set for this. I could change that if I wanted to, but if that's my limit, the software will stop at that and say, and if you look down here, it's got a deficit of about 5 BTU per square foot on that. There's a number of things you can do. You could say, well, I'm just going to increase the water temperature. If I remember right, I think 127, from 119 to 127, yeah, pretty well balances out, and it turns white, everything's good. But then if you look here, so I've accomplished that by violating the surface temperature limitation. And the software is not going to tell you that's wrong, because maybe that's an okay solution. Because again, it depends on the room, it depends on your design, and keeping in mind if you've got outdoor reset, most of the year it's not going to be at that condition. There might be 2 or 3 days a year where it gets up to this. So you've got to make that call. But if you absolutely must show that it doesn't exceed that, I'm going to reset it. You'll have this situation. Okay. So what else can we do to possibly alleviate this? And I'm going to go to a view we haven't looked at yet. It's a manifold and circuit view. Hopefully you can see those numbers. This just shows our water temperature and the manifolds under it. Again, pretty simple, there's only 2 loops here. But the key thing I wanted to point out here is this water temperature column. This shows the required water temperature. You can see room 1 only needs that 94, and room 2 needs 119. I could decide I'm going to add another water supply temperature, drag a manifold down to it. So now manifold 1 gets exactly what it needs, and manifold 2 gets almost exactly what it needs. So when I come back here, you can see now, manifold 1 gets 94, manifold 2 gets the 119. Room 1's happy, room 2 still got the overheating issue there. All right, so that's one technique you could use. Whether that's practical, I'm just going to undo it here so we get back to the other state. Whether that's practical is, again, you have to decide. You're adding more controls and more mixing valve, more piping, and so on. More cost is going into it. So, I mean, there's certainly some cases where that would make sense. Other cases where maybe it doesn't make sense. Okay, so we're back to our bad situation. So another thing, and hopefully the name of this view here, zone control issues, maybe gives you a hint. One key thing to always look at is the zoning. Okay, so, and there's a special view here as well, where it shows the zoning. So currently, both rooms are the same zone. So that means, in the software terms at least, a zone is a control zone. So think of a zone equals a thermostat. It's not a piping zone, it's a control zone. So this means there's one thermostat, it turns these both on and off, and that's why we get this issue happening. We're getting too hot of water to this room, and it can't be controlled separately. So we can change that though by right-clicking on it and make it its own zone. And voila, it's turned white. Now, the interesting thing is if you look at these numbers haven't changed. These numbers when it's on, it's still getting too much heat. But the difference is it's now can be controlled separately. So the thermostat can turn this on and off independent of the other room. And again, that's what this view is trying to show, that it's no longer considered a zone control issue. Okay, so but now we still have the issue of slight overheating on room 2. So again, you could decide, I want to get rid of that just by increasing my temperature, and now they're both white. Remembering you've done that by violating that limit, your call on whether that's acceptable or not. But they're both white, not considered control issues, even though the water temperature has gone up, so room 1's getting even more heat when it's on, but it can be controlled and turned on and off as need be. Okay, so let me reset that. Just wanted to look at one other possible thing. You might look at this and say, well, what else affects it, right? And let's go back to our bit of a list here, and you look at this, well, unit heat loss. Obviously, if you can change the heat loss of the room, that's going to affect it, maybe correct it. Maybe that's, it's probably not so practical in most cases if the design is set already. That's what it is. But you're probably not going to be happy if you start cutting windows out of the design. But one thing, you might think, what about tube spacing? So in this room here, let's try it. What happens if I change to 6-inch? You can see it's actually went to 2 circuits because of the lengths. Let me update here. There. But it's still shaded blue, and it's still almost the same. The water temperature has dropped, but you can see what's happened is we're still at that limit of surface temperature. So tube spacing isn't going to solve that problem. It lets you have a lower water temperature supplied to it, but if you hit that limit of the surface temperature, changing your spacing isn't going to help you out on it. The problem is it needs over 85-degree surface temperature to heat the room. So let me just undo that. Okay, so fundamentally at this point, then you have to decide, am I going to add some supplemental heating to this area? Or you look at it and say, well, it's not a great deal of supplemental. Depending on the room, maybe it's okay that 1 or 2 days a year it's down a degree or so. Again, it's your call. The software's not going to say it's an error as such. It's just going to give you the tools to look at that and analyze it. All right, I'm going to open up our original project with surface already drawn in it, so get something that looks a little more real world like. And we'll look at that in the system design view. Click on it right there, we go. Okay, so in this one, we immediately see there's quite a bit of red showing up and a little bit of blue down here. I've already split this into 2 water temperatures. And the main reason was the second floor I put as heat transfer plates. And so I set that as its own water temperature. But you can actually see here, they're actually both the same, 140, which happens to be the limit in this project file. So it really doesn't make sense to have 2 water temperatures, but bear with me, we're gonna look at why that's happening. And I go back to my tree view here. And if we look, So the upper floor, the heat transfer plates, getting 140. Most of those loops require 140 or close to it, which makes sense. And again, that's the limit for the project. But if I look at the main level, manifold 1, most of those loops don't require it, except that one. So this list, you quickly find that, and it's the linen closet. And if you remember, that's that blue one down there. So what's happening in the software, because the closet has a low floor area and it's got on an exterior wall, it ends up having a deficit. When you're looking at it per square foot, it ends up with a fairly big deficit. But in reality, it's a relatively small amount of heat loss to the whole thing, because it's such a small area. And we are adding some heat to it with that loop, and then frankly, I would venture to say that if you're doing forced air, you wouldn't put an air vent in that closet, an air register, and it would just be that, well, the closet's a couple degrees colder when it's minus 15 out. That's just the way it is, right? But this ends up in the software, it detects that and says, well, I'm gonna try to get my temperature as high as I can, and it bumps it right up to 140. And we don't want that, it's kind of messing up the design. So we've got the ability here, I'm going back to the floor plan step. If I pick 2 rooms, and I'm going to take the big room adjacent to it, I can merge them. So the label disappears. So what I've done, I've simply merged it with the main room as far as the heating design goes, and it just averages out those loads with this big area here. And it immediately dropped my water temperature to 128. So it's hard to see unless it's side by side, but the intensity of the red shading is less now, so that's, but we've helped it. So the next thing I would probably look at is my zoning. And in this one, again, it's one zone to start with, so that's leading to a lot of problems here. So in this, similar to what we did before, I can go and change individual rooms to be their own zone. You see they turn white right away. And this again is your judgment call as a designer, how many zones you're gonna have. In theory, every room, but practically that's probably not the best for the homeowner. I'm gonna make 4. If I go to my zone view, you'll see what I did there. So I've got 4 different zones here, and I put the bedroom 2 and its ensuite on the same zone. And I've left this bathroom zoned together with everything else here. So that's gotten rid of a lot of the red, but not all. And one, let's focus on the bathroom to start with here. I'm gonna move that out of the way. I could merge this with the big room like I did the other one. I could also make it its own zone, put a thermostat in there. But another thing I could do, I look at this and say, geez, I forgot to draw the bathtub in there and some cabinets. So I'm probably overstating how much surface area I have right now. And just to be quick, instead of going back and drawing that in, I'm going to drag these out. You can see on the left it's a 5.5 overheating right now. When I do this and update, it's actually a slight deficit what I've got, so let me bring it back a little bit. And again, update. So maybe I want to get a slight overheating, but this is probably good for a bathroom. So I haven't changed the zoning, it's still controlled with the big area, but by reducing the floor area that's being heated, I've now matched the load better. All right, so that really leaves our ensuite up here. And it's sort of a special situation with it in that, I guess overall, first of all, the floor plan, the one technique I can't do with it is add another water temperature to this floor plan, which I probably wouldn't want to anyways, because there's only one manifold. You can't have multiple water temperatures. So in this case, the bedroom and the ensuite are looped together, so it's one circuit. So I also can't make the ensuite its own zone, because I can't control half a loop. It's going to be all or nothing. So they need to be zoned together. But I end up with more heat than needed in the ensuite, and that's really because the load of the ensuite is less. It's an interior room versus the bedroom has exterior walls and windows, right? So I could also merge them together to average the loads between them. That would work as well, but I can also just use that same technique that I did and say, I forgot to put the bathtub in there. By the way, if I went and drew the object for the bathtub, I could leave the loops under the bathtub. It would still take that out of the heating area. So you can still have a warm bathtub if you want, but it wouldn't count that as being floor area being heated. So if I do that, so I end up here it shows plus 1.5, so it's slight overheating. I could continue to monkey with it and get it exact, but you also might say I like the bathroom a little warmer, so you could move on from that. And again, the issue with this one is they're controlled as a unit, so when they're turned on and off, they're still getting more heat than they need. If you look at the load versus the peak, they're both getting more, but between the two of them, they're not balanced. And with the thermostat turning them on and off will control them properly then. All right, so that gives us that.
I'm sorry, Brad, what's the difference between load and peak?
Load is what, so is your heat loss, what you're trying to satisfy. Peak is what's actually coming out of the floor. So that's why, if you find a room that is the controlling room, I can't find it here. It's probably close to this one. But if they're exactly matched, that's the one that's sort of controlling. Everything else is relative to that. So that means it's getting the right water temperature, and everything else is probably getting too high a water temperature. And how much it is, if it's in this case, this big room, the combined room, has a slight deficit of minus 1.7. Harder to see the blue. We're gonna this circuit area object is kind of blocking the color, which we'll probably look at changing. But again, you might make a judgment call on that and say, well, that's so close. I'm not going to be worried about it. There's going to be heat coming from other rooms, and again, the word approximate. All these values are going in approximate. If it's that close, it's probably okay. But you could also say, I don't want to show that deficit at all. Well, let's raise this water temperature a little bit. And you can see as I do it, the deficit's is getting less. When I get to 132, it's basically zero. So then everything's wonderful. Just keep in mind, by doing that, I've done that by increasing the surface temperature. It's only gone to 86. And again, if I've got the outdoor reset, that's probably only happening 1 or 2 days a year.
Yes.
So once again, a judgment call as a designer, whether you're going to deem that acceptable or not. So again, just to, I guess, to sort of summarize this step, there's a lot of views, and I'll look at a couple other just quickly here, but there's a lot of data that's being calculated behind the scenes that isn't apparent in these little labels that show up right away. And so these views let the software show it to you in a way that hopefully helps you analyze and make some decisions on what you might want to do. Again, your call on what that is. Another couple that I really like pointing out is these exposed floor area view. And these are available on the other steps through that analysis link here. But this one, there's also exposed ceiling. So in this case, ceiling area, the red shows where there's no rooms above it. So it's a loss, it's going through the ceiling, a loss to the outside. And that can help sometimes if you're trying to figure out why this room has more heat loss than the other room. And if you look at, this one has a ceiling loss where the other one doesn't. And you can see that in the 3D, turn the levels on. You can see where that would be happening in the 3D view as well here, for instance. But the nice thing is those views show you that in 2D. Okay. Another one I really like is the circuit temperature view. Let me just back up. Most of the normal views, you see there's flow direction arrows happening on the circuits. The circuit temperature view takes that information, and really what it does, it just shades the hot side of the loop red the return side blue, it's not trying to dictate or show any temperatures, just saying relative what it is. But if you zoom out, you get a shading of the room then. And it gives you a quick visual and say, well, I probably want my hotter water going to the outside walls, and you look, oh, there, that one I probably have going wrong. And you can fix it right here. You just right click and choose reverse flow, and voila, it changes that. So it's kind of a neat view there too. Okay, so I'm gonna just flip back here. So these are a few additional topics I wanted to mention. Again, it's the same situation, we don't have time to delve into them, but there's a quick design mode in the software. And what that is everything's the same as what we just looked at, except you don't have to take the time to draw the actual detailed loop layout. You can tell it how many circuits there are and the properties, and it'll do the calculations based on that. And if you're using one of the OEM editions where you've got materials lists and so on, it's great if you doing a quote, you save quite a bit of time by not doing the circuits. And in a month or two, if you're successful, you can open it up and put the circuits in there. So that's kind of a neat function there. Snow melt, fundamentally, as far as the software is concerned, the use of it is very similar for snow melt. Obviously, snow melt doesn't have walls, doesn't have a thing like supplemental heating, but the actual use of the software is very similar. So cooling loads we mentioned but didn't show. But if you enable that, you'll get, your sensible and your latent heat gain calculation done. It shows a plot of your fenestration or your window gains throughout the day. So that's available in there. Just a note though, just because it does cooling load calculations, it doesn't mean it does radiant cooling system design. It doesn't do that right now. So we have worked with a few of our manufacturer partners in their versions to build that in, but currently that's just an internal tool for them, but maybe down the road. And once again, the video tutorials, there's over 40 of them there, and most of them are only a few minutes long, so you can always delve into some of that. All right, that brings me close to the end. Just wanted to note there's our website and our support email address here. And yeah, so I guess first thing I want to do in signing off is thank the RPA for the opportunity to speak here. I really appreciate that. And again, thank you for getting up early and joining us here. So with that, if there's any questions, glad to take them on. Yeah.
Is there a Mac iOS version?
No, we haven't. We get asked that quite a bit, but we haven't gone down that road. Yeah. Sorry, by the way, we do have people on Macs using it. They use Parallels or something like that for Windows emulation. We don't really support it, but they say it works okay. But
are you able to integrate control valves in the design so if you have your output capacity is higher and lower, are you able to integrate, like, let's say, control valves with certain coefficients of velocity? Is this software capable of
you mean like a mixing valve or a?
basically like a valve for the zone where you can limit your supply or whatever, and like basically have control your flow in the zone, so you can have, instead of like turning off the flow of the zone and then turning it back on, just keep the flow controls. You can just serve.
Good. Yeah, I guess no. You not specifically can't add those in. If I'm understanding correct, and maybe I'm not, that's fundamentally what we're doing when we're allowing the flow to be reduced to match the load. But you would be doing that with a more automated control valve. So I think fundamentally we're doing the same thing, but there wouldn't be an object there or something to place on for that. Yeah. Yes?
Okay, I'd like to respond to that question. I think modulating the flow is a bad idea because they're getting rid of the heat at the beginning of the circuit.
Right.
And there was an abstract paper a number of years ago that looked at using heat anticipators to operate trading systems, and they work great. I lived with that for 25 years.
Okay.
Works fantastically. So that really addresses the whole overheating problem. Very, very nice.
Yeah. And that's a good point in that, again, it's the approximate word or the simplification. It talked about the return water temperature limitation. You can't reduce the flow back. Technically, you can't. You can keep reducing the flow however far you want, but as you mentioned, what'll happen is you lose all your heat in the water in the first part of the loop, and the last part, there's none happening. And so you can balance the room load that way, but it's probably not gonna be very comfortable.
Yeah, I was late, so I missed whether, I assume you can vary the resistance of the floor coverings?
Yes.
And
Yeah.
how about inputting a plan? Is that done manually or can you scan it?
You can import drawings and use them as a background to draw us quicker. So you need PDF or an AutoCAD file, you can import those. Yeah. Yes?
You mentioned the material list, that was third party?
Yeah, so we work with most of the radiant manufacturers, and there's custom versions, so you can go to our website and get an Uponor version, a Reha version, a WAS version, and so on, Mr. Peck's. And then it'll be exactly what you've seen, but it'll also have their tubing, their components, their systems, their panel types, all in, and it'll be an extra step. It'll generate a materials list and a quotation from it as well. Yeah. Yes?
Just as a follow-up, when you're reporting that, say a cat file, the supplementary report is just a floor, just one floor at a time, or could you put up all the
You would do one floor at a time if let me flip back to the software here. At the bottom, we've got these tabs that to flip between the floor plans. So you import it one at a time for that floor plan and then draw that floor plan. Even if they're on, say they all happen to be there's 3 floor plans all on the same page, you can import that 3 times and you can just work on the part that you need to. Yes?
So how is vertical wall speed?
All the walls have a height associated with them, so that's why if you want to see that in 3D, that's when you come up into 3D, and you'll see the vertical height. So if I go and change this wall to be 20 feet tall, and then I go to 3D,
But if you were putting tubing in,
I'm sorry?
you're putting something for
like a radiant wall?
Radiant wall.
Oh, sorry, radiant wall. Yeah, no, currently it doesn't support radiant wall designs. We've got a tutorial that shows how you can sort of approximate it, but it's more of a manual calculation. At some point, it's been on our list to add it, but it hasn't gotten to that stage yet. Yep.
Oh, correct. I've been using software for 20 years now. I've never heard it well explained, so here in a public setting, can you tell me in your snow melting load calculations what that wind factor is?
Yeah. So the wind velocity factor, and we've got some people that are better at snow melt than me here, I know, but I think the fundamental, or maybe hopefully an easy explanation is, if you've got a surface and you've got the wind going along it, there's a heat transfer between the air and the ground, right? But as it goes along, so it builds up a film, an air film that is heated differently along that. So the shorter that, I think they call it a characteristic length. So you pick the shortest length, so if there's a 5-foot length, you pick that shortest length in your design. That's going to be the worst case condition because that film hasn't had time to build up and you're going to have more heat transfer happening there. If you have a long distance, you get that air film building up and it sort of dampens the effects of
Are you talking about like a flat surface? Is that
Yeah.
the length that you're looking at?
Yeah, so if you've got a snow melt surface and it's got different angles or whatnot, and one part is 40 feet wide and another part is 5 feet wide, you would designed for the 5 foot because that's gonna be sort of your worst case condition. If all of it is 40 feet wide, you pick the bigger one and it'll dampen the loads. Is that, Lance, is that right?
I'd ask Robin on that.
So you were asking about the wind factor?
Yes.
Okay, so the wind factor, so the way the loads are calculated is, it looks at, 13 years of weather data. It calculates the load every hour for those 13 years, and it creates those percentiles of if you want 98%, then you need 150 BTU per square foot. And that's based on the wind velocities in that weather fund. And what the multiplier is for, it's if you have a sheltered area and you know it's not going to get the prevailing winds, you can use that wind factor to dampen the wind effect. Or if you have areas like it's going to have a wind tunnel effect, then your wind is going to be a lot worse. Like if it's around high buildings and stuff like that, wind tunnel effect can increase. So it's
And it changes it significantly.
yeah.
I would either go 0 or 1.
That's a tricky one.
So they'll have the because it's tomorrow morning.
It's just kind of tricky one.
So here, well, was it? Yeah. I don't know.
But if you leave it at the default, that is taking the weather data for that time period.
Yeah, thanks, that's probably better. I think I was completing the characteristic length along with the
So
one there
if
as
you
well.
got something that's inside the shelter, on the shelter there, it's no. Yeah, if you got something that's very sheltered from the prevailing winds, then you can use that to reduce the load down.
Yeah, Lance?
One quick one, back to the, and I haven't used Luke Cat in a while, so a lot of great new additions here. Program was wonderful. But back to the problem child, that one room was really high heat loss, and we were trying to heat. The codes like B214 allow you to have a higher floor temperature in the 3-foot perimeter area near inside walls. And you can achieve that by running the hot wire there for the type of heat space.
Right.
So you're allowed to have up to 95-degree floor surface area, and that first 15 feet, nobody's going to be sitting there. Does Luke Cat allow you to have 2 different floor temperatures in the same room, or would we have to make it a?
Yeah, no, right now it's all one. We allow you to do the tighter spacing on the perimeter, but we don't actually calculate different temperatures in each right now. It just, we work with the averages for the room to get the approximate heating, but yeah, that's a good point.
But in real life, if a quarter of the room can be 95 and the other 3/4 is 85,
Yeah.
it's not mathematically say, okay, we'll have an average floor temperature, whatever, 87.5, but you're not actually going to overheat the interior.
The interior part,
So,
right?
yeah,
Yeah.
the designer can equal it.
No, that's a good point.
Maybe that be serpentine at all, so the wall is 2 windows on it.
Yeah,
And like those traditional.
yes, but currently the software doesn't go to that level of calculation. It'll still calculate the average for the room. So even if you put 6-inch along the outside, fundamentally that's better, but the software's not going to do it. Yeah. Time? Oh, I'm getting that hook.
Thermostat with a slab sensor, you still get that overheat from temperature, if you get a warning, if you have a slab, or no?
Well,
Set my slab sensor at 80 or 80 smart free.
yeah, I mean, you'll still, if the load is still high enough, you'll still get the overshoot. Anyways, I'm being told I have to end it now, so again, thank you everyone. It's been great that you met with us this morning.